EPLAN Emulate 3D. So 4 years ago, Rockwell decided to purchase Emulate 3D, and they now have a simulation software. So the software is to simulate machines in 3 dimensions, but not just simulate them so it's simulating the mechanical aspect. So now what you have to do is you have to manage the control system. So the PLC controller has a specific code, and you have to tie that code to all of the sensors and actuators on the machine. And that can be done through an interface that Emulate 3D provides. So you can technically, or not technically, you can physically connect a PLC 1756 rack with all of the controller, the I/O, and everything like that. You can connect it to a laptop, and that laptop and the PLC will then drive the simulation environment. And in the simulation environment, you can interact with the model. So you can press a start button here, you can press a stop button here, and then it will actually directly give feedback to the PLC and then back to validate your PLC code. So it's a really, really cool tool. And again, I suggest to you guys, if you go to the Emulate 3D booth, I'll let them give you a little demo of the tool. It's really neat to see how it works. So one of the challenges of creating those simulation models, and it's true for various different simulation tools, is the time that it takes to create those models. So the mechanical aspect can be imported from any CAD tool. So if you have Autodesk Inventor, SolidWorks, CATIA, whatever, you import the 3D models. But now you have to make those 3D models move. So this is where you have to now substitute certain blocks or give certain blocks some movements, associate some movement to them. But also you have to give them the logical dependencies, meaning that if I press this push button, this motor needs to go on. If I hit this stop button, this motor needs to stop. And this is done here in the wiring diagram of Emulate 3D. So they go through, technically they open up schematics, they look how everything's wired, and then they recreate the schematics in this wiring diagram of Emulate 3D. And this takes a lot of time. This can take, depending on the size of the control cabinet and how many cabinets they have, can take anywhere between 2 and 4 days per control cabinet just to make sure that you have all of the devices captured and all of the wires and the signals captured in Emulate 3D. So now, if a user of Emulate 3D opens up the schematics and is trying to interpret the schematic to create his Emulate wiring diagram, why not create an interface that allows the user to open up an EPLAN schematic and just export all of that data from EPLAN and import it into Emulate 3D to already jumpstart the creation of all of these wiring diagrams. And that's just what we did. So from EPLAN, now we have an XML interface. Again, it's a proof of concept. It's not a product. We do not sell it. There's no price on it yet. So it's a proof of concept, but it's a working proof of concept where from EPLAN you can export the data from a project to XML. And then that XML file, you can hand it over to the Emulate 3D engineer. He can import that file, and 75, 85, and depending on how accurate you are, even up to 100% of the wiring diagram can be recreated automatically inside of Emulate 3D, which really saves the designers in Emulate 3D a lot of time. And the logic is technically already there, so you know what is wired to what. So if you press this button, you want to make sure that it's the right motor that's connected to it. Well, through the schematics, you can make sure of that, and that information is transferred to Emulate 3D. Through this import, you can also match the part numbers. So we import not just the devices, we import the connections of the devices, the wires, and also the part numbers. So we have a list of all the part numbers that are in the EPLAN project, and you can map these part numbers to the Emulate 3D blocks with various different parameters. And you can also import all of the connections, meaning the signals. So that way you have the blocks and you have the signal numbers, and then you have automatic linking between signals that have the same name. So that's where in the EPLAN environment, the wire numbering according to signal number is important, so that all of the connections that are connected together have the same wire number. And that's what Emulate 3D uses to tie all of the signals together. So on that note, here we should be able to see there's a video. The video I think is about, what is it? It's 4 minutes long, but I typically stop it at halfway through because then it goes into too much detail. So you see there the schematics and the 3D Pro panel. They go into import schematics, click on this button, select the EPLAN XML file that we created from our schematics. And then it tells you, okay, these are the control panels that are in that XML file. Then it tells you these are all the parts that are in each control panel. And then you can specify whether you want to import them or whether you want to ignore them or what is the import action to be done. So it's like a validation interface to validate the parts coming in to Emulate 3D. And then the third window shows you all of the parts, the devices, and for the devices, it shows you all the connection points. And on each connection point, it shows you what is the wire number coming in to or connected to that connection point. And once this is imported, you'll see now suddenly you've got 4 control panels that appear in the Emulate 3D environment. One is the power distribution panel, and the other 3 are just the motor panels. And on the right-hand side, you can see the wire diagram. And that wire diagram was created by importing the data from EPLAN directly. So it's really cool how that just created, because creating this from scratch in Emulate 3D would have taken a while. And here you just imported a file and you create it. So here you can see he activated the circuit breaker. The circuit breaker turned the stop light on. Now you can turn the start button. The start light goes on. The motor starts turning. And all of this is thanks to the wiring information provided by EPLAN and automatically connected in Emulate 3D. So then you can stop the button. The motor stops. One of the benefits here is now you can validate power supplies too. So if you shut down the main power, are all the motors going to shut off? If you shut this circuit breaker, is it going to shut down the entire line, or what is going to turn off? So it's really cool to see how you can validate the wiring diagrams from EPLAN inside of that 3D model. So if you want, you can look at the rest of the video. It's a little bit longer, but we'll just skip it for now. But it's a really nifty interface, and again, a tremendous time saver in terms of creating the simulation model. And that's always been a challenge up until now. It's if creating the simulation model takes way longer than me actually building the machine and troubleshooting it in the live thing, then what's the purpose of the simulation model? But we want to get to a point where you can create the simulation model really, really fast, and then at the end validate it before you even started building, and know exactly that when you build it, it's going to work correctly. So what is this? How does this add value? So first of all, it significantly lowers the engineering investment to create these wiring schematics. So as I mentioned, instead of anywhere from 2 to 6 days, depending on how big the control panels are and how much it is, well, you could do this now in pretty much 15 minutes, depending on how much data is coming out of EPLAN. And even if you get 75% of it, that's already a tremendous amount of work that's been saved. Instead of spending days, you just now spend hours in adding the missing components and connecting them up. So it's, again, a big time saver. It helps you to rapidly assemble control panels from catalog items. It helps you to risk the amount of errors from manually recreating in E3D. Because if you were doing a manual takeoff from schematics, every time you type in the signal, well, you could have mistyped the signal and entered a different signal name. And now you're spending a whole bunch of time troubleshooting and figuring out what's wrong and what's not working. And now that becomes a bit of a challenge. And then finally, you can validate your EPLAN schematics, because if you press on that button and the other motor at the end of the line turns on, then it's probably your wiring diagram that's not been connected properly. So either the tagging is wrong or the wiring is wrong, but it kind of helps you also to validate the wiring diagram and make sure those are correct and according to what is needed.